Hello everyone, and welcome to the DataFrames lecture. In this lecture, we're going to finally learn about data frames building off of the series object. DataFrames is going to be their main tool when working with pandas. Let's go ahead and jump to the Jupyter Notebook to see how it all works. Alright, here I am at the Jupyter Notebook. I'm going to go ahead and say import numpy as np and import pandas as pd. And I'm going to do one last thing here. I'm going to say from numpy.random import randn. And then I'm going to go ahead and set a seed. And what a seed means is just to make sure that we get the same random numbers. That way, if you're following me, you'll see the same random numbers that I see. So you can go ahead and say np.random.seed. Alright, let's go ahead and explore the DataFrame command. I'm going to say df is equal to pd.dataframe, and you can actually use tab here if you're using Jupyter Notebook to autocomplete this. And notice that the F is capitalized. I'm going to do shift tab to check out the docstring and the initial signature for this PD data frame. We have a data argument and an index argument, just like we did for series, but then we have this additional columns argument. Let's go ahead and build this up with some random data, and we'll see what a data frame actually looks like. First thing I'm going to do is pass in that data argument, and I'm actually just going to call randn 5, 4. And then the next ones we want to pass is the index. And the index, we can just make that a list of characters here. I'm going to go ahead and say A, B, C, D, E. And then finally, for the columns, I'm going to go ahead and say W, X, Y, Z. So I'll say W, X, Y, Z. I'm going to go ahead and run this, and then pass in the data frame just to display it. And there we get a nice display, and this probably looks and feels a lot like Excel if you're using a Jupyter Notebook, and that's good. If you're using another IDE editor, you may not get such a nice crisp display, but you should get a printed output that looks similar to this. Alright, so basically what we have here is a list of columns, W, X, Y, Z, and corresponding rows, A, B, C, D, E. Now, each of these columns is actually just a pandas series. So W is a pandas series, as well as X, Y, and Z. And they all share a common index. And that's basically all DataFrame is. It's just a bunch of series that share an index. Let's go ahead and show how we can use indexing and selection to actually grab one of these series objects, or several of these columns out. One way, and the main way to do this, is by saying df, and then using bracket notation, and then passing in the column name. In this case, let's go ahead and grab the W column. So as a string, I'll pass in W, and this returns the W column. And now take a look at the output. Now this actually looks like a series. And that's because that's exactly what W column is. It's just a series. And you can actually confirm this by saying type of df of W, and it shows that it's pandas.core.series.series. If I just say type on the df object itself, I will get a data frame out. So again, just to reiterate that fact, that a data frame is just a bunch of series that share the same index. Now, there's two different ways you can grab a column from a data frame. The main way, and the way you should always do it, is using this sort of bracket notation and then pass in the column name. However, if you're really familiar with SQL, a lot of times when you're selecting a column, you pass in a table, dot, and then the column name. This actually also works for pandas. You could say dot and then the column name. However, I would recommend that you don't use this because it may get confused with the various methods that are available off of a data frame. For instance, if I say df dot and then click tab, I see a whole bunch of methods available for me. And those are a bunch of methods that we're going to learn about as we learn more about pandas. But what may happen is that one of these methods gets overwritten by a column name, and then pandas is going to get confused whether you're asking for a method or an actual column name. So what you should do to avoid that is always use this sort of bracket notation when requesting a column. Okay, if you want multiple columns back, then you can go ahead and pass in a list of columns. So note that I pass in my brackets, and then I'm going to pass in a list of column names, which is going to result in another set of brackets here. For instance, if I wanted columns W and Z, I pass in a list, here highlighted, W and Z, and I get back a data frame containing those two series. And that means when I ask for multiple columns, I'm actually getting back a data frame. If I ask for just a single column, then I will get back a series. And in the Jupyter Notebook system, that's denoted by the way the output is displayed. Okay, let's go ahead and move on to creating a new column. Pandas supports creation of new columns by just specifying the column as if it already exists. For instance, new. Now if I run this, I'll get an error, and it's a key error. If you scroll all the way down here, it'll say key error, new, and it basically just is trying to tell you that it can't find it, that there is no key new there. However, when you're creating let me go ahead and hashtag that out and put this back in. When you're creating a new column, you can actually define it as if it already exists, and then on the right-hand side of this equal sign, use other columns with arithmetic in order to pull off a new column. For instance, we can say df new column as if it already exists is equal to dfw plus dfy, and this will run with no error. And now if I check out df, that new column is actually in place there. And for removing columns, you can say df.drop. You can say df.drop and pass in the actual column name you want to drop. Now, if you just do this by itself, you'll get an error. And let's go ahead and check out what that error is. It'll say value error, and if we scroll down, it says labels new not contained in access. And if I click Shift Tab on the drop method, notice that by default it says access is equal to 0. Access is equal to 0 for the drop method refers to the index. If I actually want to refer to the columns, I need to specify access is equal to 1. And then it will drop that new column here. Now there's two things to note when using this df.drop. The first thing to note is that this doesn't happen in place, meaning I'm not actually affecting this data frame unless I specifically specify this to occur in place. I'm going to go ahead and show you what I mean by that. I've called this line df.drop new access equal to 1. If I call it df, I'll see that I still have that new column. That means I need to actually specify as an argument, and we'll do Shift Tab to show it, the in-place argument. And many pandas methods will require this in-place argument to be set to true. And the reason pandas does that is that for you not to accidentally lose information. In case you've done a bunch of adjustments to your data, you don't want to accidentally lose it. So pandas requires you to say in place equals true if you actually want a lot of these changes to stay and occur in place. And now if I call df by running this cell, notice that new column is now permanently removed because it occurred in place. And something to note here is that we can also use df.drop to drop rows. For instance, let's go ahead and use this to drop the E row. I'll say df.drop, I pass in E, and I can also say access is equal to 0. Now remember, you actually don't have to add that in as an argument, that's the default. So let's go ahead and just say df.drop E, and there we've been able to drop the E since access is equal to 0. And it works either way. I could say access is equal to 0, and this will work again. And note here I'm not doing this in place. Okay, sometimes a point of confusion is why are the rows 0 as far as their access, and why are the columns 1? Well, the reference actually comes back to NumPy, since data frames are essentially just fancy index markers on top of a NumPy array. To show this, I can say df.shape, just like we did with a NumPy matrix. And note, df.shape is a tuple for a two-dimensional matrix here, and at the 0 index are the number of rows. So if I say df here, I have 5 rows, A, B, C, and D, E. And then on the index 1, I have 4 columns, W, X, Y, Z, which is why rows are referred to as the 0 axis and columns are referred to as the 1 axis, because it's directly taken from the shape, just as you would with a NumPy array. Okay, now let's talk about selecting rows. We've talked about selecting columns, which you just do by saying df, and in brackets, you pass in the column name. Or, if you want many columns, you pass in a list of the column names, such as z and then comma x. Let me close off that bracket. So I'm passing a list of column names, and I return a data frame of those multiple columns. Let's talk about selecting rows. I'm going to take a look at my data frame again. Here's my data frame. A, B, C, D, E is my rows. W, X, Y, Z are the columns. There's two ways to select rows in a data frame. And you have to call a method off of this. And there's two methods to use. One is loc, L-O-C, for location. And this is going to take in a label. So you can also do Shift-Tab here to see this property. And something to note here is I'm using square brackets, which is a little weird, but that's the way it works with pandas. You pass in .loc, and then you pass in brackets the row you want. For instance, if I wanted the A row, I just pass in .loc, and I pass in the label of that index. And this returns, note, a series. And this comes to our second conclusion that not only are all the columns series, but the rows are series as well, as far as the way they're going to get returned when you request them in pandas. Now let's discuss the second way to grab a row, which is based off of index position. I can use df.iloc to actually pass in a numerical index position even if my axes are labeled by strings. For instance, if I want C, that row, I can do that two ways. I could either say df.loc for location, and in brackets pass in the row name, which is C, or I can say iloc, which is index-based location, and count what index it's at, so 0, 1, 2, and then on iloc, pass in 2, and this also returns that row. And that basically means you have two ways of selecting rows, using loc if you want the location or labeled-based index, or iloc if you want the numerical-based index. Okay, let's talk about selecting subsets of rows and columns. And this will actually be very familiar to you since we've just learned about NumPy. We can say df.loc if we want to select a subset of rows and columns. We can pass in, just like we did with NumPy, using comma notation, the row we want and then the column we want. So I want the value at row B, column Y. And this returns just a single value there. So if I take a look at my df again, looking at row B, column Y, I have this negative 0.84, and I get the same result here. So just like NumPy, you can use this row, comma, column notation. And if you want a subset of this, you can say df.loc and then pass in a list separated by commas. For instance, let's say I wanted the subset of A, B rows with the WY columns. So basically I wanted this 2.7, 0.9, and 0.65, and negative 0.84. That means I can just pass in a list of the rows I want, which in this case is A and B. And then I can pass in a list of the columns I want. In this case, that's W and Y. Shift enter that, and I get this subset return of the data frame. Okay, we're going to stop it here for now and continue this discussion in part 2 of the data frames lecture. And this is all in the notebook called Data Frames under the Pandas folder. Let's get a quick review of what we've learned. As far as creating a data frame, you just need to say pd.dataframe, pass in your data, pass in your index, and then pass in your column names. Usually we won't be building data frames by hand in this manner. We'll actually be reading data from some sort of source, like a CSV file, but we'll learn how to do data input and output later. For now, if you want to manually create a data frame, that's how you can do it. Then, for selecting columns from a data frame, you can say df, and then in brackets, pass in the column you want, or pass in a list of the columns you want. And remember that each column is actually just a series. You can create new columns based off of old columns by using this sort of arithmetic. Then you can drop columns or rows using df.drop. Remember, you'll need to say in-place equals true if you want the effect to be permanent. You say axis 1 for columns, and then axis 0 for rows. And again, that comes from this shape tuple. 0 index was rows, 1 index was columns. As far as selecting rows from a data frame, there's two methods here. There's the .loc method, which is a labeled-based index location, or there's the .iloc, which is the integer-based index location. And then if you want to select subsets of the data frame, you can use .loc and pass in either values or complete lists to return subsets of the data frame. Okay, that's it for the very basics of data frames. Coming up next, we're going to discuss even more of what you can do with a pandas data frame, such as using conditional selection. Alright, thanks everyone, and I'll see you at the next lecture.